Good morning everybody, and we're back with Maths IGCSE, and we are still working through the solving of linear equations, exercise 6.2, and you should have worked through the exercises and the section, and now we're going to work through questions 4 and 5. Question 4 and 5. 4 and 5. So you should have been able to do question 4 in any case, because there's not really anything new there. But question 5 involves exponential equations, so it's a little bit different. But let me just do first question 4c. Just as an example of the type of question that we have in 4, and that is 7x minus 3x plus 11, 3x plus 11, and that is equal to 6 minus 5 minus 3x. Okay, so what we have to do first thing is we have to multiply these brackets out. Notice this bracket here has got a minus in front of it. In other words, it's multiplied by minus 1. So you've got to multiply this by minus 1 and this by minus 1 before you can remove the brackets. So therefore, 7x minus 3x minus 11 is equal to 6, and with this one it's exactly the same, minus 5 plus 3x. Minus times a plus gives a minus times a minus gives a plus. And now we're going to get all our x's on one side. We can subtract this 3x from the 7x and make it 4x, so on. And we can bring this 3x over by subtracting 3x and subtracting 3x. So it's got minus 3x. Okay? And here we're going to add 11 to both sides. So we're going to add 11 here. So we get 6 minus 5 plus 11. And this becomes x. Therefore, x is equal to 12. 6 minus 5 is 1 plus 11 is 12. No, nothing new there really. Now, I'm going to work through the whole of question 5 because it's exponential equations, which is something new. So 3 to the power of 3x is equal to 27. So when you see that x is in the exponent, you know you're busy with an exponential equation. So you need to know your laws of indices, and the best thing to do is to convert your numbers all to exponents of prime numbers, powers of prime numbers. This 3 is already a prime number, so we can just rewrite it. Therefore, 3 to the power of 3x is equal to. How can we write 27 to powers of a prime number? Well, you should know that 27 is 3 to the power of 3. 3 3's are 9, 3's are 27. 3 times 3 equals 9, times 3 equals 27. So we write it as 3 to the power of 3. So now the rest of this is very easy, because the only way that this whole thing can be equal to that thing is if 3x is equal to 3. So if we have the same base, we can just equate the powers. Now we can solve it, and you can actually solve this by inspection, because this can only be true if x is equal to 1. Or you can divide both sides by 3, you'll get the same answer. Okay? We move on to 5b. 5b, we've got 2 to the power of 3x plus 4 is equal to 32. Same thing again, this is a prime number, so we just rewrite it, 3x plus 4. And we've got to express 32 as a power of a prime number, and we want that prime number to be 2. Otherwise it's not going to work. And we know that 2 to the power of 5 is 32, because 2 to the 4, 2 to the 8, 2 to the 16, 2 to the 32. That's 5. Now we got the same base, so we just say 3x plus 4 is equal to 5. And then we've got a normal linear equation to solve, which is quite easy. Subtracting 4 from both sides, therefore 3x is equal to 5 minus 4, and therefore dividing both sides by 3x is equal to, subtracting this gives us 1, dividing both sides by 3 gives us 3. So therefore x is equal to 1/3. Five C is 8.1. 4x plus 3 equal to 1. Okay. Now I was very confused by this because there is a practice of writing a times sign with a point. We can write 8 times 1 as 8.1. So you sometimes see that, but notice that this dot is in the middle. It's halfway. It's not at the bottom. Okay? So this is a decimal. It's a decimal. If you like, we can put brackets around it. I actually prefer that. So we got 8.1 to the power of 4x plus 3. Now what do we know? When is an exponential equal to 1? So we know that x to the power of 0 is equal to 1. 365 to the power of 0 is equal to 1. 1,6325 to the power of 0 is equal to 1. That's your exponential laws. So your exponential laws says that this can only be equal to 1 if 8.1 to the power is to the power 0. If 8.1 is to the power 0, then it will be equal to 1. So if 8.1 to the power 0 is equal to 1, then 4x plus 3 must be equal to 0. Okay? So anything to the power 0 is equal to 1. And then we've got our linear equation, subtracting 3 from both sides. Therefore 4x is equal to minus 3, and therefore x is equal to minus 3/4. Here's your answer. Okay. This is a favorite of these. Doesn't matter what it is, if it's equal to 1, if you've got an exponent, it's to the power 0. There was 5c, now we do 5d. 5d. 5 to the power of 2. 3x plus 1 equals 625. Okay? So, what is 625? I don't know, but I want to find out. So all I do is I start dividing so that I can break 625 out up into its prime factors. So I know I can divide by 5. 5 goes into the 1 and carry 1. 5 goes into the 2, carry 2, 5 goes into the 5. 5 goes into there, 12 goes into the 2, okay, carry 1, 5 goes into, carry 2, 5 goes into 25, 5 times. We've got 25 here, 5 goes into 25 5 times, and 5 goes into 5 times. So, 625 is, if we work back, 5 times 5 times 5 times 5, we'll get 625. So therefore we know that this is actually 5 to the power 4. So we can replace 625 by 5 to the power 4. And we write therefore 5 to the power of 2, 3x plus 1 is equal to 5 to the power 4. And this can only be true if 2, 3x plus 1 is equal to 4. We can, let's not multiply our bracket out. Let's just divide both sides by 2. So if we divide this by 2, it becomes 1. So we can take away our brackets, 3x plus 1. We divide this by 2, we get 2. So we've now divided both sides by 2. We're going to subtract 1 from both sides, therefore 3x. This 1 becomes 0. We subtract 1 from this side, we get 1. Okay? And therefore, we're going to get rid of 3, so we're going to divide by 3. This coefficient here becomes 1, so it's just x. And if we divide this by 3, we get 1/3. So x is 1/3. Right. (5e) 4 to the power of 3x is equal to 2 to the power of x plus 1. So, this one's a little bit different. You've got to change this 4 to a base 2 to an exponent, which is really quite easy, but remember to put it in brackets. Let's show you why. 4 is 2 to the power of 2. But this 3x is outside. So we put brackets there and we put the 3x outside. So this is exactly the same. This is 4 to the power of 3x. This stays as 2 to the power of x plus 1. Now we can use our other law of exponents that says when you've got an exponent outside the brackets and inside the brackets, you multiply them. So this is therefore 2 to the power of 6x. Equal to 2 to the power of x plus 1. And our bases are now the same, so we can say 6x is equal to x plus 1. Subtracting x from both sides, subtracting x from 6x gives us 5x. Therefore, 5x is equal to 1, which is left over, and we're going to divide both sides by 5, so x is equal to 1 over 5. Right, last one now, which is 5f. 5f, we have 9 to the power of 3x plus 4 equal to 27 to the power of 4x plus 3. So this one is actually the same as the previous one, there's just more of it. We're going to change our 9 as a power of a prime number. So 9 is 3 squared. And outside the brackets we still have 3x plus 4. And then we change that to 3 to the power of 3. And then outside the brackets we have 4x plus 3. Now we multiply our powers. So we got 3 to the power of 6x plus 8. And this is equal to 3 to the power of 12x plus 9. And there our bases are now the same, so we can write therefore 6x plus 8 is equal to 12x plus 9. And there you've got a normal linear equation that you can treat as usual, subtracting 12x from both sides. 6x minus 12x is equal to 9, subtracting 8 from both sides, minus 8. And these two give us minus 6x, and these two give us 1. So therefore, x is equal to minus 1, 6. And there's your answer. Okay, I hope that sorted things out for you. Thank you very much.